YouTube channel. My name is Salami Adini, and the topic for today is differential calculus continuation. And last class we tried to look at the meaning of differential calculus. That is, what is the meaning of differential calculus? We said differential calculus simply means what? A rate of change of one variable with respect to another variable. And we said we don't have anything called dy dx. What we have basically is what? The left function, the d of the left function over the d of what? Of the right function. And we try to look at the two principles for differential calculus, which is what? The first principle and the formula method. We also try to look at the product rule. And to continue for today, we'll be looking at what we term as what? The substitution method. And the substitution method is still the same thing as what? The function of a function. Some textbooks call it as the function of a function. It is still the same thing as what we term as what? As a chain rule. And when we are talking of the chain rule, it simply means what? Y is a function of x. Don't forget, this is the normal function of differential calculus. But now, this function itself will not be having a power. That means what? It is a function inside another function. For example, if we have it as y is equals to 2x plus 4 all squared, we can easily expand this one. And this one will give us what? 2x plus 4 into what? Into 2x plus 4. And if you expand, what do we have? This time this will give us what? 4x squared. This time this will give us 8x. And that will give us what? 16x plus what? Plus 16. And from this we can easily what? Differentiate. And this will give us what? 8x plus what? Plus 16. This is still easy just because we are having it as a power of 2. But what of if we are not having it as a power of x? Are we going to expand? It's not possible. And that will now bring us to the principle of what? Of a chain rule. That is a function inside another function. And for the principle of a chain rule, we have a formula which is what? Dy over it as what? Dy over what? Du times what? Du over dx. And that is the principle of what? Of the chain rule. This function will be your u and then you differentiate. For example, let's look at this question. If y is equals to 2x plus 8, a power of 11, they said we should find our what? Dy over dx. And how can you solve it? You cannot expand the power of 11, though it's possible, but it will waste our time. So what we are going to do is what? We are going to assume our u to be the function for the bracket. And since we are having it as u is equals to 2x plus 8, that means we are not going to make our, we are going to get our du dx, and if we differentiate it, this will give us 2. And after getting your du over dx, you go back to the question, and coming back to the question, we have it as y is equals to this function now is your u, a power of 11. And then this is another function you differentiate. Don't forget, this is a function, we have differentiated it. This is another function, differentiate it again, and that will give us what? Dy over du is equals to what? U, 11u, a power of what? Of 10. And from this, what is our dy over dx? Don't forget, dy dx is having a formula which is what? Dy over du. That means this function times what? Du over dx, and that is this function. And what are we going to have? Then you multiply them together, and that will give us what? Our dy over dx is equals to, what is our dy du? That will give us 11u, a power of 10, times what is your du dx? That will give us 2. So if you multiply, what do we have? We have it as what? 22 what? U10. And are we having u in the question? No. So what is your u? Your u is what? 2x plus 8, a power of 10. And that is how we differentiate, making use of what? Of function of a function or a chain rule. Now for us to now solve further, let's look at this. We have y is equals to what? 2x plus 3, a power of what? Of 5 over 2. Wow. So how can we solve this? Still the same process. That means your u is equals to the bracket, and that is what? 2x plus 3. You differentiate, what do we have? Du dx, that will give us 2. And then you go back to the question after having the first function, and that will give us y is equals to what? U, a power of what? Of 5 over 2. And then you differentiate. And this will give us what? Dy over du is equals to, don't forget, the constant here is 1. So multiply, what do we have? 5 over 2u. Now this is 2.5 minus 1. That will give us 1.5. And what is 1.5? That will give us what? 3 over 2. And that is all. And then you multiply the two functions together. So what is your dy dx? That will give us what? Dy du times what? Du dx. And if you multiply this and this, we have it as what? 5u a power of what? Of 3/2. And are we having u in the question? No. What is your u? Your u is what? 2x plus 3 a power of what? Of 3/2. And that is the basis of what? Of function, of a function, or the chain rule. Now, but if we are solving CBT questions or OBJ questions, we are not going to be making use of all these long principles. How are we going to do it? Let's look at this. We have y is equals to 3x minus 5 a power of 6. They said we should find the value of y prime. So how can we get our y prime? That means we are not going to look at the shortcut, and the shortcut is having a formula of what? Of anx into what? Into n minus 1. Now don't forget, the a in the previous one is what? Is constant, and your n stands for power. But now here the a and the n and the x will change. And what is your a? Your a stands for what? The differential of the bracket. That means we are going to differentiate this bracket, and if you differentiate this bracket, your a is 3 and your n still remains your power. But your x will not be x again, your x will not be the bracket itself. So let's look at this. What is our y prime? Our y prime is what? Is a. Differentiate this bracket, we have 3 times what? N. What is the power? 6 times x, the bracket itself. That will give us 3x minus 5, n minus 1. 6 minus 1 will give us what? 5. And this one will give us what? 18 into what? Into 3x minus 5 in power of 5. And now let's keep on solving more questions on this. We have y is equals to the fifth root of 3x squared plus 5x minus 2. We are told to look for what? For y prime. Wow. How can we solve this? That means we are going to remove this fifth root, and that will give us what? 3x squared plus 5x minus 2 a power of what? Of 1/5. You know, fifth root is 1/5. And what is your y prime? Make use of the shortcut. A. Differentiate the bracket. If you differentiate it, this will give us what? 6x plus 5. N. What is the power? 1/5. X. The bracket itself, 3x squared plus 5x minus 2. N minus 1. And that will give us what? 1/5 minus 1. So solve this. This will give us what? 1/5 into 6x plus 5 into what? 3x squared plus 5x minus 2. Now, 1 minus 5 will give us what? Minus 4/5. And in mathematics, it is a taboo for you to leave your answer like this. What will happen to this negative? It will come down, and that will give us what? 6x plus 5 divided by what? 5 into what? Into 3x squared plus 5x minus 2 a power of what? Of 4/5. And you can see it is simple. And that is that about what? The function of a function. And not to waste time, let us move on to the next function, and that is what? The trigonometric function. So we want to be looking at the differential of what? Of some trig function. And under the trigonometric function, before we look at the differential, we have to understand some bases concerning what? The trigonometric function. And what are the bases? We must know the inverse of what? Of trig function. And what are the inverse of trig function? We have it as what? The inverse of sine, the inverse of cos, and what? The inverse of tan. And what is the inverse of cos? We have to know that the inverse of cos is what? Is cosec x. And what is the inverse of cos? We have to know that the inverse of cos is what? Is sec x. And what is the inverse of tan? We have to know that the inverse of tan is what? Is cot x. What is another thing we need to know? We need to know that what? Our tan x is having a formula which is what? The sin x over what? Over cos x. So knowing all this under the trigonometry, we can now look at what? At the differential of what? Of trigonometric function. So we need to know that the differential of sine will give us what? Cos x. We need to know that anytime we are differentiating cos x, the differential of cos x will give us what? Minus sin x. We need to know that anytime we are differentiating tan x, the differential of tan x will give us what? Sec squared x. we need to know that anytime we are differentiating sec x, the differential of sec x will give us what? Sec x tan x. We need to know that anytime we are differentiating cot, the differential of cot will give us what? Minus cosec squared x. And lastly, we need to know that anytime we are differentiating cosec x, the differential of cosec x will give us what? Minus what? Cosec x cot x. So knowing all this, we can now solve questions under the trigonometric function. And now, for if you want to derive all this, we can derive, but time might not really permit us to derive. But for example, if you want to find the differential of tan x without arriving at sec squared x, all these differentials are being gotten from what? From the mixture of product rule and quotient rule of what? Of trigonometric function. And now let us solve this. What is tan? Another formula for tan is what? A sin x over what? Over cos x. And this is what we term as what? As a quotient rule. We are still going to look at it, but for the sake of this video, let us solve it. That means our u is equals to sin x and our v is equals to what? Cos x. So differentiate this will give us what? Du dx. If you differentiate sine, what is the differential of sine? Cos x. And if you differentiate cos, what is the differential of cos? That will give us what? Minus what? Sin x. And after this, what is the formula for quotient rule? We need to know that the formula for quotient rule is what? V du dx minus what? U dv over dx divided by what? V squared. And knowing this formula, we are now going to insert all our functions inside it. And that will give us what? Y prime is equals to v times du dx. So if you multiply this together, that will give us what? Cos squared x minus u times dv dx. Multiply that together, that will give us what? Minus sine squared x divided by what? V squared. And what is your v squared? That will give us what? Cos squared x. And what do we have here? This and this will give us plus. And also from the trigonometric function, we need to know that what? Sine squared x plus cos squared x will give us 1. And that will give us 1 divided by what? Cos squared x. And what is your y prime? The inverse of cos will give us what? Sec squared x. And that is why the differential of tan will give us what? Sec squared x. And we can keep on solving more functions and more functions. But what we just need to know is what? All other functions, that is cot x, cosec x, or sec x, every other functions have been derived from either the product rule or what? The quotient rule of what? Of trigonometric function. So we can try that, and then you will send it to my DM, and then we will try to look at it together. Now let's look at questions under the trigonometric function. For instance, they are going to mix questions together with what? With function of a function. And we are going to look at the long principle just for 2 questions, and then we switch over to the shortcut, the short approach, what you need to know. Now we cannot differentiate sin 3x, but we can differentiate sin x, we can differentiate sin u. So that means these multiple functions, we are going to assign a variable to it. And the same thing as the chain rule. And this will give us what? Du dx. And what if you differentiate this? This will give us 3. You go back to the equation. Y is equals to what? Sin u. Differentiate. What do we have? Dy over du. Differentiate sine. What is the differential of sine? Cos u. And what is your dy over dx? You multiply the 2 differentials together. So if you multiply these together, what do we have? We have it as well 3 cos u. And what is your u from the equation? Your u is what? Is 3x. And that is that about that. Now let's solve one more question, then I will now teach you the shortcut. We have sine 3x minus 2. So how can you differentiate this? U will be the function in front of the trigonometric function, and you differentiate it. Du dx will give us 3. After getting your first function, go back to the question. We have it as what? Y is equals to what? Sine bracket. What is your bracket? U. And then you differentiate. This will give us what? Dy du is equals to what? Cos u. So we have gotten the first function and the second function. Then what is your dy dx? Your dy dx is the mixture of the two functions, and that will give us what? 3 cos what? U. And are we having u from the equation? No. So what is your u from the equation? That will give us what? 3x minus 2. And that is that about that. Now, if they are now asking us this question under the OBJ aspect, how are we going to solve it? Knowing fully well that for you to pass OBJ, it is your speed and accuracy. So how can you solve it? This is the shortcut. Your dy dx will just be the differential of the function in front of the trigonometric function. So we are having sine as the trig function. What is the differential of 3x? That will give us 3. And then you will now come back to the trig function and then you differentiate. If you differentiate sine, what do we have? We have it as what? Cos the function. And that will give us what? 3x. And for instance again, let's look at this. Y is equals to what? Cos 7x. How can you differentiate? That will just give us what? Dy over dx is equals to, what is the differential of 7x? That will give us 7. Then come back to cos and differentiate. Differentiate cos, what do we have? Minus sine what? 7x. And this will give us what? Minus 7 sine 7x. Now let's look at another question. We have y is equals to 4 sine 6x squared minus 2. And how can you solve this? We have looked at the shortcut, and that will give us what? Dy dx is equals to differentiate this function. That will give us differentiate this. We are going to have it as what? As 12x. Don't forget, the differential of a constant is 0. And then come back to this function and differentiate. Differentiate sine. What is the differential of sine? That will give us cos. What is the function in front of it? And then you multiply. This will give us what? 48x cos what? Cos 6x squared minus 2. Now let's look at this. We have y is equals to what? Cosec 9x. Wow. So it's simple. So what do we have? Our dy dx will give us what? Differentiate this function in front. That will give us 9. Now don't forget, what is the differential of cosec? That will give us what? Minus cosec x. But now here we are not having x. What are we having? 9x. Cot x. What are we having there? We have it as differential of cot. So what we are going to do is to rearrange, and then we will have it as what? As cot x cubed all squared. Wow. I'm giving you the shortcut here. And now, what are we going to do here? Look at this. It is no longer trigonometric function alone, but it is trig function involving what? A function of a function. Do we get that? And how can we differentiate this? Making use of a function of a function. The shortcut is what? An x into what? Into n minus 1. And that will give us dy dx is equals to a. Differentiate this bracket. And don't forget, if you are differentiating this bracket itself is a function of a function. Do we get that? A trigonometric function of a function. And how can you differentiate this? That means we are going to differentiate the function here. This will give us what? 3x squared. You differentiate cot. And what is the differential of cot? That will give us what? Minus cosec x. But we are not having x. We are having it as what? X cubed. And then cot x. We are having it as what? As x cubed. Do we get that? We have it as anx into what? N minus 1. Our a means you differentiate this bracket. So if you differentiate this, what do we have? We have it as what? 3x squared. This will give us minus cosec x cubed cot what? Cot x cubed. Now multiply by n. What is your n? The power. Multiply by x. What is your x? We have said it that your x is what? Is the bracket itself. Now into what? Into n minus 1. And that will give us 1. So this will not show again. So if we are having this, what are we going to do? That means you multiply, and then you multiply them based on their like terms. So what is cot x cubed times cot x cubed? That will give us what? Cot squared x cubed. 2 times this will give us what? 6. So you can now see that what is the differential of y cot squared x cubed? It will give us what? Minus 6x squared cosec x cubed cot squared x cubed. Now let's look at this again. We have y is equals to what? X cos x. Now How can we solve this? This is a principle, is a mixture of what? Of product rule. That means how can you solve a product rule? Your u is the first function and your v is what? The second function. Then you differentiate. We have it as well. Du ds is equals to 1. The v ds will give us what? Minus sin x. And after differentiating, what do we have? Then you make use of your product rule formula, which is your dy ds is equals to what? U dv over dx plus what? Plus v du over dx. And then you insert all your function. So what is u dv? This times this will give us what? Minus x sin x plus this times this will give us what? Cos x. And that is the principle of what? Of the trigonometric function. So without wasting time, let's look at the last aspect for the sake of this video, and that is what? The exponential function. And when we are talking of the exponential function, what are we saying concerning the exponential function? E stands, denote what? Exponential. And now we must know that if we are having it as y is equals to e raised to power x, how can we differentiate an exponential function? For you to differentiate an exponential function, this is the trick behind it. It will be the differential of the power. Whatever is here, you differentiate it times the question itself. So what is the question here? The question is what? E raised to power x. And if you differentiate x, 1 times what? E raised to power x. And what do we have? E raised to power x. And again, let us look at this again. We have it as what? Y is equals to exponential ax. How can we find our what? Our y prime? It's simple. What do we have? The y over ds is equals to what? The differential of the power multiplied by the question itself. So multiply it by the question, differentiate this will give us what? Ae exponential what? Ax. Do we get that? It's simple. And let's look at this. We have it as y is equals to what? Exponential x squared plus 5x minus 2. How can you solve this? That means what is your dy ds? We have said it. Your dy ds will be what? The differential of the power multiplied by the question itself. So multiply it by the question itself, and then you solve. Differentiate this will give us what? 2x plus 5 into what? Exponential x squared plus 5x. Let's look at the next aspect, and that is talking about the higher or derivative. And what is the meaning of higher derivative? Higher derivative simply means we know before that we are having dy dx, and this is what we term as well the first derivative. And if we want to look for the second derivative, your second derivative is having a function which is what? D squared y over dx squared. And this is what we term as what? The second derivative. And the same thing, it continues like that. The d cube y over what? Dx cube. And this is what we term as what? The third derivative. And what is the meaning of higher derivative? That means for the first derivative, we are going to differentiate our y. For the second derivative, you are going to differentiate your first derivative. For the third derivative, you are going to differentiate your second derivative, and so on and so forth. Now let's look at this. We have if y is equals to 3x raised to power 4 plus 5x cubed minus 6x squared plus 1. We are told to find our y prime, and what? Y prime prime. So if we are looking for the y prime, what is the meaning of y prime? You differentiate your dy dx. Differentiate this will give us what? 12x cubed plus what? Plus 15x squared minus what? Minus 12x. And differentiate your y prime prime. That is the second derivative. Differentiate this again. That will give us what? 36x squared plus 30x minus what? Minus 12. Differentiate y prime prime prime, and that will give us what? 72x plus what? Plus 30. And that is the meaning of what? Of higher derivative. And from this, let us now mix the principle of higher derivative with the exponential function. And this is the question. We have it as what? If y is equals to x exponential 2x, we are told to show that y prime prime minus 4y prime plus 4y is equals to 0. Wow, I love this question. This is a mixture of product rule, function of a function, and what? An higher derivative. So how can we show? That means we have gotten our y from the question. That means we need our what? Our y prime. So what is your y prime? We are going to differentiate this function. And for us to differentiate, your u is a product rule, your u is x, and your v is what? Is exponential what? 2x. So differentiate this, du over dx will give us 1. Differentiate this, we have said it several times. You differentiate the power, we have it as well 2 exponential what? Exponential 2x. And what is your y prime? Make use of the formula u dv dx. So this time this will give us what? 2x exponential what? 2x plus v du dx. Multiply this, we are going to have it as what? E exponential what? Exponential 2x. Exponential 2x is common, and that will give us what? 2x plus 1. And this is what? Our what? Our y prime. So let us get our y prime prime. And what is the meaning of your y prime? Your y prime prime. Your y prime prime means what? We are going to differentiate this our y prime again. And for us to differentiate, your u is equals to what? Exponential 2x. Your v is equals to what? 2x plus 1. So differentiate this, du over dx will give us what? 2 exponential 2x. The v over dx, differentiate this, that will give us 2. Are we getting that? And what is your y prime prime? That means we are going to make use of the product rule formula, u dv. Multiply this together, 2 exponential 2x plus v du. Multiply this together, we have it as what? 2 exponential 2x into what? Into 2x plus 1. And from this, 2 exponential 2x is common. What do we have? 1 plus 2x plus 1. And what do we have? 2 exponential 2x into what? Into 2 plus 2x. And that is what? Our y prime prime. So we are going to substitute everything inside this function. And we are having y prime prime. What is your y prime prime? That will give us 2 exponential 2x into what? Into 2 plus 2x. Minus 4y prime. What is your y prime? That will give us what? 4 exponential 2x into what? Into 2x plus 1 plus 4y. So what is your 4y? That will give us what? 4. What is your y? X exponential what? 2x is equals to 0. So now let's prove that everything will be equals to 0. So expand this. This time this will give us what? 4 exponential 2x. This time this will give us what? 4x exponential 2x. This time this will give us minus 8x exponential 2x. This time this will give us what? Minus 4 exponential 2x. And then we have it as what? 4x exponential 2x is equals to 0. So from this, what are we going to have? We can see that 4 exponential 2x minus 4 exponential 2x will be 0. And what is 4x exponential 2x plus 4x exponential 2x? That will give us what? 8x exponential 2x minus 8 exponential 2x is equals to 0. So if we subtract this, we have it as what? 0 is equals to 0. And that is the end of what? Of the exponential function. So you can see that all these things are easy. So this is where we are going to stop for the sake of this video. And for the next video, we are going to continue from the logarithm function, taking it to the implicit function, taking into the curve sketching, taking into what? The inflection point, taking it to the maximum and the minimum point. I remain my humble self, Titiano. I love you all. Please don't forget to like, don't forget to comment, and please don't forget to subscribe.